Good day. Today we will be talking about our next lesson, which is about procedural abstraction and functions that return a value. These are the following topics that we will discuss in this chapter. We will talk about top-down design, predefined functions, programmer-defined functions, procedural abstraction, local variables, overloading function names, and everything that we need to know about functions in C++. But first, let's talk about top-down design. When we are dealing with functions, it is important that we must first understand the concept of top-down design. When writing a program, we've already learned that we need to develop the algorithm that the program will use. And of course, after that, we need to translate that algorithm into the programming language, which is in this case, we are using the C++ programming language. But what about with top-down design? In this approach, we first break down our problem into smaller and more manageable parts. In this case, we can break the algorithm into subtasks. And if required, we can also break each subtask into smaller subtasks. And eventually, the smaller subtask will be much more easier to implement using the programming language of your choice. There's a lot of benefits when we use the top-down design approach. For instance, in C++, this would make your program easier to understand, easier to change, easier to write, easier to test, easier to debug, and of course, if you are working in a team, this would also be much easier for the teams to develop a program. Talking about functions, there are different kinds of functions in C++. First, we have what we call the predefined functions. When we say predefined functions, these are functions that comes with C++ in the form of libraries. Usually, these kind of functions are stored in C++ libraries. For example, we have the square root function. To use this, we can simply declare a variable, for instance, this particular variable, and then simply assign it by using the function call. And in this case, we would like to get the square root of 9. Whatever is the result of this computation, this will be assigned as the new value of this variable. What the square root function does is it returns the square root of a number indicated in this parenthesis. In this case, the number 9 is called the argument. For a function, an argument is required. In this case, given the square root function, the argument is required, hence we place the number 9. And the result will contain 3. Let's talk about function calls. In the previous example, this is a function call. What it does is it invokes or sets in action the square root function. Whenever the C++ compiler sees this function call, it means that we would like to invoke whatever action is associated with the square root function. In this case, the argument 9 can also be a variable or an expression which returns a value. A function call can be used just like any expression, just like this one or this one. Let's take a look at an example. As we can see here, we have a sample program which uses a predefined function. In this case, we are using the predefined function square root. If you will notice, we have here a new include directive. As you can see here, we are using another library. In this case, we are using the CMath library. We included this in our program using this particular include directive. Without this, we won't be able to use the following predefined function. What it does is to simply calculate the area using this particular expression. And of course, the most important part here is to demonstrate the use of a predefined function. For instance, let's run this program. Let's say I would like to enter the following value. And that's the output of our simple program. Next, let's talk more about the details of a function call. Basically, the syntax of a function call is, of course, to indicate the function name that we would like to call, and inside the parentheses, we must include the arguments. In this case, a function can have one or more arguments, which are indicated in the argument list. In the case where the argument of a function is more than one, we can simply separate them using comma. In this case, the argument list is separated by commas. For example, we have this. In this case, the function square root only requires a single argument. On the other hand, the function power requires two arguments. In this case, they are separated by a comma. As we have mentioned before, when we talk about function libraries, this is where predefined functions can be found. And in order for us to use those predefined functions, the library must be included in a program to make the functions available. Hence, the include directive that we did a while ago in our previous example. An include directive, if we will recall, tells the compiler which library header file to include. Like in the previous example, we only used the IOStream library. This time, since we will be using predefined functions such as square root and power, therefore, we need to include the library that contains them. In this case, the CMath library. Newer standard libraries such as CMath also require the directive such as using namespace std, which we will talk more in detail as we go. We also have some other predefined functions. Actually, there's a lot of predefined functions in C++ aside from what we've seen a while ago. In addition, we also have the following. What it does is it returns the absolute value of argument x. Also, predefined functions which requires arguments also require a certain data type for their required argument. For instance, here's another example. What it does is it returns the absolute value of the argument x of data type x, which in this case, double. This function can be found in the CMath library. Here are some of the other functions that we can use and their description. If you would like to explore this, you can simply read about this and, of course, its details in the ebook that will be given to you. In C++, we also have the concept of typecasting. If we will recall, we encountered the following problem in our previous lesson. For instance, let's recall the problem with integer division. We have the following expression. In this case, the variables total candy and number of people are all of type integer. On the other hand, the following variable, candy per person, is of type double. If we will continue with the following expression, what will happen here is this. The variable candy per person will have a value of 2 instead of 2.25. To solve this problem, we need to use typecasting. For instance, if we are going to use typecast, this will produce a value of one type from another type. Simply said, we are going to convert the data type of a variable to another data type. For instance, if we are going to do the following, it will produce a double which would represent the integer value of total candy, which in this case, the cause of this particular error. Here's a more detailed example. In a previous example, we have the following declaration. And take note that they are all of type integer. And as you can see here, if we would like to produce the correct result, which are also of correct data type, we simply need to typecast the following variable. In this case, we are going to convert total candy into type double through typecasting. And of course, to do that, we simply do this. Then we indicate the data type that we would like our variable to be converted to. By doing so, we can now expect a correct output. This would also work. In this case, we are going to typecast the variable number of people. However, doing this one is not going to work for the reason that integer division occurred first before we do the typecasting. Therefore, we must be careful when we are dealing with this particular type of typecasting problems. The thing is, it would be much safer for us to simply declare our variables using the correct data type. That way, we no longer need to do typecasting since our variables are already in its correct data type. Aside from this example, there's another way in C++ to do typecasting, which is the old style typecast. This is the older method of typecasting which may be discontinued in future versions of C++, although it would still work in most of the compilers that we have. Here's an example. We now learned about predefined functions in C++. Here's some exercise that you can do by yourself. As you can see, predefined functions are very handy to use, especially if you need to do something without having to code from scratch. For example, you can do the following. You would like to determine the value of determining the square root of a given number, the absolute value of a given number, and you can even combine different predefined functions just like what we have here.